Howdy, everybody. How are you? Awesome response. So yeah, I'm Mike Nichols. I'm joined by James. He's the smart guy. I'm going to go fast to get to the cool stuff. As was mentioned, I work at Elastic. Before you all groan, don't worry. This will be as agnostic as we can and more educational as we can. Both of us, before being in the vendor side, were practitioners. I'm a U.S. Army veteran, and I spent a lot of time in security operations centers, including large ones like DHS. So hopefully we bring a little bit of air of information here to you about what we're talking about. Show of hands, who wants to hear more about AI? Who hasn't heard enough about it yet at RSA, right? AI seems to be the talk of the town. We're going to talk maybe more about applied AI today, actually, not futures, but actually current and values of what it offers. I'll put some slides up. I won't go through these. You can read them if you want, but I think the way we looked at this, looking at generative AI, so last year, right, I was a skeptic. Last year, we're seeing AI come out. We're seeing generative AI models and all the kind of things it can do. And like everything in security, we're a bit skeptical if it actually can truly solve a problem. So what we decided to do was look at the areas of an analyst's life that suck, which, let's be honest, like the majority of it does suck. I love the job, but 10% of the job is what you love to do, and 90% of the job is like data mangling and talking to people to try to get access to systems and trying to sift through 1,000 false positives to find the things that matter most, right? So how do we get the 10% to be more like the 80 or 90% of what you do? Because we all have problems with retention. Analysts burn out. 18 months is like a lifetime. You might as well get pension at that long in a company if you're an analyst. And alert fatigue or whatever buzzword you want to hear is actually real. When I was at DHS, we'd have tens of thousands of alerts a day. You start churning through them. And what I talk about a lot when I talk about these things is it feels like every time we find a real problem, it's more like serendipity. It's I hope I picked the right one, or I have some kind of my own personal guess and check way to find the problem, and I hope that I can figure this out. Or maybe I'm sitting next to James, and James mentioned something that I saw previously, and that relates to this. And there's too much of that still in the SOC. The way that technology has evolved, the feedback mechanism should start to be automated. I'm a big believer in the OODA loop. Anybody follow the OODA loop? Yeah, so the OODA loop, famous military kind of doctrine by a fighter pilot that moved his way into analytics. And the key part of the loop of the OODA is that you're supposed to go from the final A back to the O again, right? But no one ever has time to take the lessons learned and feed them back into their systems to make it better and more practical, even though we need to. And so we said, well, look, can AI help us in these areas, the areas of the SOC? Can it remove those challenges? And what we're going to talk about today is that alert inundation problem, the sea of alerts we get. You're at RSA, right? Go down to the show floor, and every new product under the sun promises to solve all your problems, and they do that by producing a bunch of additional alerts. So you had your already too many alerts. You're going to add some more alerts. You're going to throw them into a SIM where they get more alerts, and all of a sudden you have this like massive overload. So where do you start, right? The question is always, where does my team begin? This impending doom that we all feel of, I'm never going to get through this list, and tomorrow the list will not be any smaller, it'll just be bigger. So how do I avoid this, challenge of, again, burning out the analyst and saying, look, I'm done. I don't want to do this anymore. I like to say that, we hire detectives and we make them beat cops, right? How do we make them do the things that they love to do? So let's talk about the challenges. Again, read these if you want. But the key frustration, again, is I'm in this big list. I know somewhere in there is probably a problem that matters in the sea of false positives, in the sea of challenges. And how do I discover that? We have different ways of looking at it. I used to do grouping by a rule name, and then you sort by count. And if it's a lot of alerts, you assume it's a false positive. If it's a little bit of alerts, maybe that's a true one. Go start there. But again, that's not scientific. That's more experimental. So how can we get better? Right? Like, how can we actually make a programmatic, systematic, repeatable way to help our analyst team find what's in the middle? I go back to, when I first got in this space, I remember one of the biggest first news articles was Target. You remember the Target breach from many, many years ago. But what was exciting about that one, or maybe compelling about that one, was it was one of the first times we heard a company call out a vendor. They're like, hey, we got breached, but we were running FireEye. We don't know what happened. And then FireEye comes out and goes, no. They had the alert. It was in the system, I promise. And it became this like, oh, you had it, but you didn't analyze it. And so it really exasperated this issue that you probably have this signal somewhere in the noise of a problem happening in your environment. But if you can't pull it out, if you can't prioritize it, if it doesn't go to the top of the list, it gets lost, right? And so that's the key challenge. How do we get the most important thing you need to look at every day at the top of the list so that your tier 1 analyst can look at it and the tier 2s and 3s can go fix it? And the other key piece is this can't be some new process. As a product vendor, I always tell people, maybe against my own best interests, the last thing you should invest in is product. In that people process technology funnel, technology is at the bottom. You really got to fix your processes and make sure people are educated to how to use those processes. It's also the most expensive part of the SOC before you invest in new technology. So how can we add to an existing process and improve that as opposed to adding some net new process that is a new training mechanism, things like that. So enter AI. Again, first time you've ever heard of AI, I'll explain it to you. We've heard about AI all over the place. What we like to talk about is that I think AI is sort of the third evolution or maybe the revolution of what was classically SIM. I think SIM's a bad word. It's another four-letter word at this point, right? SIMs have been a lot of negative connotation to them. They started as big log collectors because in the security team, when I was at DHS, for example, and I had a problem I needed to solve, I had to get access to the DNS proxy or the DNS server or to the proxy or to the firewall because those logs were not in my security purview. And that was time, that was energy, that was copy pasting. So we thought, hey, let's make one big new monolith where we can keep security data. But then security data started to keep growing. Oh, wait, that's also security data, and that's also security data. Log4j happens, we go, you know what, application information is also security data. The cloud transformation means that SaaS information is also security data. So at the end of the day, your SIM became basically a replication of all your other data in one big monolith that needed management, orchestration, and somewhere to pay for it. We evolved a bit better from there and started adding detections to it and remediations to it, but still it was that problem of being an alert factory. We think that SIMs need to change, right? We're sort of in this third evolution where they are more like your central analytics solution or maybe like your operating system within the SOC. It's the place you go to correlate, contextualize all the information from all these disparate sources and find the things that maybe were missed by other technologies. It's that third area where we think Gen AI can really play a key influence. And when we talk about AI, and you'll see James demo it here in a minute, which will be much cooler than just hearing me babble on, is that it can't be, again, like a separate thing. Chats are cool and powerful, and we'll even show you how we have an assistant. It's been generally available since last July. But that can't be the end-all, be-all, because that's not the current workflow your team knows. Each of those core workflows in the SOC need to be enhanced sort of almost invisibly behind the scenes by AI in order for it to truly show an influence or a difference in your systems, in your technologies. So how do we do that? How can we take that problem I talked about, that alert list, or I say list, it's more like Cascade or Avalanche, and figure out a way to bring the most important thing to the top? Well, enter the amazing part of large language models. So we're going to talk about AI here in a minute. James is going to come up and talk about how these work. What I want you to think about as you're hearing James talk and hearing the demo is AI is an inevitability. Much like the cloud transformation, you will start having things that have AI, like your services like Okta and others were just cloud. You didn't have an option. AI is going to start getting embedded into your technology. So it is a matter of if, it's a matter of when you start to embrace AI in the organization. As James talks to you about all these different parts of AI, he's going to talk about the challenges as well. And things like security, things like privacy, things like cost. They've already started to be mitigated, both in sort of how models have started to evolve over time, and also how companies have implemented those AI technologies, like you'll see with Elastic. So as James comes up, he's going to talk about this, and he'll actually show you in action us taking an alert Avalanche and curating that to the most important thing that matters with the power of large language models. James?
Thank you, Mike. Good afternoon, everyone. You've made it to the end of, what is it, day 2 of RSA? So thanks for sticking in there. So before I get into the demo, and Mike teed me up, and no pressure there, it's all good. So we're going to talk about some of the challenges, and one of the things you should look for to combat these challenges when you're starting to embrace generative AI. Like, yes, we're a vendor, but yes, we should also give you advice about how to combat some of these things. Some of them would be things like, I get asked all the time about, hey, how do you deal with hallucinations? What about the complexity of a generative AI stack? How do we make our data accessible in a private way to our large language model? All these things. So let's talk a bit about those before we get into the demo. So first, I'd like to talk about a technique called retrieval augmented generation. This is it's a bit of a fancy term, but in reality, what it allows you to do as someone who's using a product is supplement the knowledge of a large language model with your data in a very private and secure way. So what happens is when you implement something for retrieval augmented generation using something like a search engine or a vector store, when you ask a question or when a question to a large language model is asked on your behalf, we use semantic search, so natural language search, to be able to retrieve the right data that you're already storing. And when we say right data, this could be playbooks, it could be threat intelligence, it could be reports that you've already generated. Would grab those based off the term that you've asked the large language model, retrieve it, and then send that to the model to be able to give you the concise answer you need for your question. These models are trained on an extensive amount of data, but hopefully it's not your private data. So this is how you can get across that barrier without the expensive cost of having to train models. Security data changes every single minute. This helps with that. So you don't have to retrain a model every time your data changes. You just apply retrieval augmented generation. So incredible technique that works really, really well for the use cases we're about to show. These arrows are animated. I didn't know that. There we go. OK. And these are some of the differences. I spoke about like why training your own models is not the best of ideas. Very expensive, very time consuming. And again, every time your data changes, you're going to incur that cost again. So this is where retrieval augmented generation comes in, because it runs at runtime. When you ask the question, that data is retrieved, the data that potentially came in a minute ago, right? So that's why it's so, so powerful. So what should you look for? Like, this is just some general advice from us as Elastic, what you should look for to combat some of the objections to using AI in your organizations. So for hallucinations, retrieval augmented generation is generally the answer there. When you supply the right context to ground the model, then you're going to reduce the chance of hallucination dramatically. I'll never say 0 hallucinations, because that's like saying 0 false positives. And no security vendor should ever tell you that. But we're able to reduce that dramatically. Security and privacy is really, really important, especially if you're using a third-party large language model, like most of us will do. We'll use OpenAI, we'll use Azure, we'll use Amazon, we'll use Google. So when you're looking for these tools, look for tools that allow you to anonymize data, redact it, run role-based access control on top of it, everything that's typical. But sometimes we forget about these things in the generative AI era. So whatever platform you should look for should really allow for this, as well as being really open and transparent. So what I mean by that is, don't be afraid to ask, what model do you allow me to use? Can I use my own? Can I run an offline version of a large language model? These are things that any vendor that you work with should allow you to do. And the last objection is about cost. So this time last year, when we were working on the first version of the assistant, I was, apart from hallucinations, probably the #1 thing people would ask me, how much is this going to cost me to run if I'm using a third-party large language model? Aren't they really expensive? The good news is that there's so much competition in the large language model market now that they are no longer expensive. They are dirt cheap to run at scale. So to the point where there are models by Anthropic, for example, the Claude 3 family of models, the Haiku model, it's like 0.000001 cent per million tokens, which is essentially free. So make sure that you make yourselves aware of how quickly these models are advancing, because they're not only becoming cheaper, they're becoming faster and even more accurate. So what I'm about to demo uses all these techniques, something we've called attack discovery. This is brand new. We announced it on Monday, going to be available to all our users in a few weeks. Essentially what we're doing is we're grabbing all those hundreds of alerts you have in your workflow. We're applying retrieval augmented generation on top of them. We're adding anonymization. We're allowing you to redact the data or add any data that you want. Bring in any large language model you choose and that you prefer. And then we've created this beautiful interface for you to find the exact attacks which are happening in your environment. And you'll see this in the demo. This is not a gimmick. This doesn't become another list of things I have to go through. These are the active attacks which me and my team need to focus on right now and eliminate all the other noise. So that being said, I'm going to show you this because it's really, really, really cool. All right, let's go ahead. So this is Elastic Security. If you're not too familiar with Elastic Security, this is our alerts page. So more specifically, hopefully it's coming across the screen, this is where me, as James, the analyst, I would typically start my day and start to cry a bit when I start to see hundreds of alerts there that I have to go through. I only have 114 today, so it's a slow morning, let's be real, right? And if I start to scroll through these, I start to notice how many different types of alerts there are, various different severities, various different criticalities, different systems. I have alerts from SentinelOne in there. I have network-based alerts. Where the heck do I even start from? This is something, if you work in security operations, you know exactly what I'm talking about. If you manage teams that work in security operations, you know exactly what I'm talking about. And every time we start to try and start to filter these and try to identify where I should start, that clock is ticking. So instead, we're changing the game, right? We're not going to need your teams to do this anymore. So I'm not going to go, I'm not even going to bother throwing one. I'm just going to pivot to attack discovery. And this is the simplest interface in the world. We've given you one button. It can't get easier than that. You can see I have my model selected up here. We're allowing you to select whatever model that you like. I have a whole list in there because different models perform in different ways. I'm going to hit the generate button. And this could take a while depending on how many alerts you have. I don't want you to have to wait for that. So I'm just going to show you a copy I ran just about 2 hours ago. And I want you to digest this output. And I'll run you through it because it's pretty remarkable. So we went from 114 alerts, or whatever that number was. And up here, hopefully you can see, 11 out of those 114 are actually ones that matter. These are actually ones that, James, you should be looking at these 11. Out of those 11, they make up one discovery, one attack. So in the background, what happened when I hit that generate button, we retrieved all that data. We anonymized it. We sent it to the large language model with a very specific question and very specific context, and it identified that perfect discovery out of those 114 alerts and the 11 alerts which matter. Let's look at how it described this to me. So a discovery is really, really simple. You can see here it's made up of a title, a summary, and the details, and also the MITRE ATT&CK chain. So let's read it. Say, listen, there's a malicious Excel macro which led to a compromise and data exfiltration. A really, really simple title. And then it shows me the entities which were involved. Like, listen, the user James on this particular host opened a malicious Excel file that executed a macro to download and run malware. The malware then port scanned another host which was compromised and had data exfiltrated from it. Perfect, right? If I'm an analyst and I read this, I sure as heck know why this is a discovery. I definitely want to know about this. All the workflows my team might be used to are there, as Mike was saying, so we haven't taken those away. If I want to see, oh, show me this host, what's its criticality, what's its risk, I can see that right from the discover. Same thing for the host, same thing for the user. Now let's look at the summary. So in here, it told me even more detail about what happened. There was a multi-stage attack that was detected, starting with user James on this host, opening that Excel file. The malware then port scanned this particular host, which appeared to have been compromised. A Java process spawned a shell that downloaded an attack script from a malicious domain. The scripts were used to package and exfiltrate sensitive data in this particular zip file to an attacker's Slack channel. So a perfect natural language description that I can identify what happened. If I need more detail, it's right there. Here is the name of the malware. Here's where it was decoded to. Here is the port scan range that was used. So it identified perfectly the exact attack, what happened. This isn't faked data. This is a real exploit that we ran that I built specifically for this conference, and it picked it up in that mess of whatever else was going on. We don't stop there, right? So if I'm an analyst and I see this discovery, great. Can you tell me which alerts actually contributed to this? I might want to dive into one or the other of them. Absolutely. So we also show you that. So we have this alerts view where if you want to, you can pivot to it. I like to say alerts become the new logs. Like I can pivot to it should I wish. We don't hide any of that from you. And I can see all those 11 alerts which contributed to this discovery. One thing I'd like to highlight is, as Elastic, as an example, and this should be hopefully true eventually for every tool, we allow you to bring in anyone's data. Because you might tell me, oh, maybe this is working well because it's an Elastic agent or an Elastic data set. No, none of this is actually Elastic native data. This is actually coming from a third-party EDR platform, SentinelOne, I'll just open and say it, and also AuditD on Linux, which pretty much every organization under the sun uses AuditD. So nothing is Elastic specific here. We just bring it in and give you extreme value from it. So if I take any of these and I want to inspect them, I can. If I search for SentinelOne, for example, I could do that. You can see this is coming from SentinelOne. So these attacks, because they can span so many multiple technologies, it's really important that if you have everything in one place, that the discovery can take that into consideration. We don't stop there, though. So you might tell me, OK, this is great. I saw everything, really, really powerful. What if now a tier 1 or even a tier 2 or tier 3 wants to continue this investigation further? We've given you all the tools to do that. I can say, open up our timeline with all those alerts, one click. And now I can pivot into any search, visual, correlation rule that I might want to do to pivot from this data set. We can take it a step further. What if you've told me what happened, but I need to know how to remediate this? Well, in comes the assistant, right? Something we've had for the past year or so. So I can click this one button. It sends that discovery to the assistant. And you can see it gives it a perfect name and everything. And you can see I'm actually using a different model for this. So it goes back to I'm using the right model for the right task here. And I can ask the question. I can say, hey, how would I remediate this? And you can see I have a pre-saved prompt in there that I just clicked. I didn't type this out because this is something I might want to ask over and over again. So I'll just hit the enter button there. And now, because the assistant has the right context from the discovery, it's going to be able to give me this really rich remediation advice. And if you're looking at this advice, it's good. It tells me what to do, what artifacts to clean up, reset the user's credentials. This guy, James, always messing up. Monitor for suspicious activity, update your incident response plan, so on and so forth. So really, really powerful. At every stage, I can utilize this, right? One thing I should have shown before I did this was, the actual investigation part is half the battle. Where we spend most of our time is reporting and following up on this, right? So why don't we make that easy as well? So instead of someone from my team having to go spend an hour typing in a report, formatting it in Markdown, whatever formatting tool I use, let's click one button to do that. So I can go ahead, take action, add this to a case. Everything is pre-populated, assign it to me, click the button. That's it. Oh, that's a known error. So that's OK, because it's a live demo. So if I go to cases, I'll show you that. And this is it. So you can see this is what happened here. It added all the content to the case 10 seconds ago in its already formatted state. So I didn't have to spend the time doing this, right? That's perfect. That's exactly what I would want to see. Not only that, but I have all the alerts attached as well, which is great. So I didn't have to do any of that either. If I was a security operations manager and someone from my team sent me a formatted report like this, I'd give them a raise, because that's great. Like, this is exactly what I'd want them to do and not have to waste too much time to do it, which is amazing. We can also go back to the assistant and add the remediation advice to the case. And we've also made that easy because it's one click away. So now, not only do we get the discovery, we get all the rich information from the remediation advice as well. So that's also been added now in its formatted state. We don't have to stop there. What's even better is, let's say I want to investigate James even further. I know James is up to something here. Maybe his account was compromised or whatever. I've used the timeline, but you know what? I would really like a query that would let me hunt further. So thanks to the power of the assistant and thanks to retrieval augmented generation, we've given enough knowledge to the assistant to be able to craft our queries in our query languages. So I'm going to go ahead and do that. I have a pre-saved prompt here as well that's going to ask me to generate ESQL as our piped query language, but it's going to look in the discovery, identify the user, and craft a query for me that will allow me to hunt further for this user's behavior within all my data set. Not only that, but you'll see in the response, we provide one button to pivot from the query itself to the actual running of it. There's no large language model in the world which knows about our query language, by the way, because it came out a few months ago. So this is retrieval augmented generation in action, which is really, really cool. And now I can click this button here. Let's expand the time range a bit. And now I can see everything that James did over the last 7 days or so. So we went from a mess of alerts, an actual attack discovery, creating a case, finding out who did it, following up, adding another search, which can search across all my data sets in a couple of clicks. And this is why we feel it's so real. It's inevitable. This is so powerful to do. And anyone can do it because it's so easy. So that's some of the things we wanted to highlight as part of the demo. There's so much more we could show, but it's in the interest of time. I did want to show one more thing, which is, you saw me give an attack discovery for one discovery. Obviously, if you have more data, it will find them. So I'm just going to let this run for you so you see it. If you have multiple discoveries, we've also made sure that they display correctly. So that's also really important. It's not just one thing, working with third-party data. We want to make sure that this could work if there's multiple things happening. So this is a specific data set crafted to make sure that we can show that. I'm just going to let that run a bit so you can see it. But that's it. That's like, hopefully that's sunk in for you because it's so powerful. And we're so excited. We're just getting started here, and we really feel this is where we should take the industry, right? It's not a gimmick. It really works well. It really makes people's lives easier, and it's just a few clicks away. Generative AI is here. It's making things much, much better. So with that being said, I'm going to pivot back. We have a few more slides for you. Actually, let's just see if this is finished. That's still going. I don't have to wait for that. All right. So we've already got some early feedback about this. This is an excellent guy called Kadir from Bolt. If you're not familiar with Bolt, Bolt is basically the Uber of Europe. I don't know how many countries they're in, but we gave him a sneak peek of Attack Discovery. He fell in love with it. Has already been using our assistant within Bolt. Tremendous feedback there. So we're really, really keen to get it into the hands of everyone to keep seeing feedback like this. That was the demo. So just a few more things from us. Like, this is Elastic Security as a whole. Yes, there's all the generative AI stuff, which is really cool. This is everything else we do. You bring in any data that you like you saw. This is why we call it extended protection, because if you have data from pretty much any type of EDR vendor, cloud security vendor, we can bring it in and make it actionable, as you just saw. We're not just being another place where you dump data and spend money to keep it there. We'll make it actionable for you. We do also have, by the way, our own native agent, right? So if you didn't have something in your environments and you wanted to supplement it with what we call Elastic Defend, we have that too. So if you did want to run like a native protection from Elastic, we do that as well. And everything you expect from a SIEM. Like you saw detection engine cases, and all of this is powered by our Elastic Security Labs team, which is an incredible set of researchers who day in, day out publish new content. We just published something about large language model security as an example. Highly recommend you check it out as well. So that's us. We have our booth obviously downstairs in the Moscone North. We have a bunch of demos online. You can go to our brand new webpage, I should say, elastic.co/security/AI. If you didn't get enough of me, there's myself giving a recording of a similar attack scenario with Discovery. We also have a clickable demo on that website that you could go through. And yeah, hopefully you're as excited as we are about all of this stuff. We have some time for questions, if anyone wants to take and ask us any questions about this.
Don't be shy.
Now's your chance.
I'll come up here and get you fired up. Let's do questions. Let's go. Who wants to ask something? Oh, look at this brave gentleman. Let's give him a round of applause. All right, sir.
All right. This isn't going to. Hopefully, this doesn't sound as much like a downer as I hope it does. As I hope it does not sound like a downer. But I got a good question. For the past 30 years or so, about every 5 years, somebody says, "Hey, I've got this thing. I've solved detection." I mean, the first you had vector-based analysis of TCP/IP connections. You had machine learning. You had UEBA, and you got rule-based stuff, and every time it runs into exactly the same problem. People are noisy.
Yep.
People are darn noisy, and so please convince me how this demo, which was run in a sandbox with high-fidelity alerts and looks beautiful, this could, I mean, even if it isn't any better at detection, generating reports is a really nice thing.
Yeah, for sure.
And how is this going to be not a failure? Well, how is it going to be a big advance over what we've had before? Because it's been a disappointment every time up till now.
For sure. Maybe I'll start and James can go.
Why is it different this time?
Go ahead.
So I'll start with, I appreciate the skepticism because I'm also skeptical. The first thing I'd say is you can try it. Everything, you can download this, try it yourself, run it in cloud.
Oh,
but I think the key thing about this, the reason why I think this is different is because all the things you mentioned previously were net new technologies, net new workflows. You know, okay, we have UEBA now. Now we need to hire a UEBA expert. We need to learn how do you build UEBA rules, how do you triage those things. What AI is, what we hope AI's implementation is now, is it's actually augmenting all the existing things that already are there. So you're not starting to learn some net new thing, you produce the net new capabilities, But now it's basically doing the job, the suck part, right? It's taking the stuff you already have and trying to sift through that for you. There's, whether it's this or the remediation steps, it's the same thing a human can do. It's just doing it in a way that's faster and hopefully prioritizing the work that you need to look at. Jay, if you want to talk more about the model itself.
I'll just say,
yeah.
large language models as a technology as a whole, we've never had anything like that in the industry. We've never had a technology that allows us to grab data and have it deal with it like a human would in a very, very efficient way. That's why we're so excited about it, because we've been trying to solve this problem for years. And like you're saying, there's a big promise of technology and it fails. From what we've seen with this, there's a big promise and it's succeeding. So even in the past year or so since we've had just the assistant, we've never had a feature adopted so quickly because people are using it and saying, this is actually solving a problem. So it's really, just to go back to your original question, it's the large language model era that's given us a technology to work with. And we still don't know everything it can do. I saw Jeff Bezos describe it as a large language model is like a telescope. We've looked through this telescope, we still haven't discovered everything we could do with it. And that's the difference here. Large language model is a real technology that's really working. When you add additional context and additional information, it works even better. So that's why it's different. And that's why we've invested so much in it, because we've actually seen it work. This is a demo series, of course. It's not an enterprise production environment with 50 billion hosts or whatever. But the data it has, even at scale, it found it. It's real. Like we didn't craft what you saw like specifically for today. There was a bunch of extra stuff in there just to try and confuse it. Like, it's real. Like I hope it's sinking in, because it really is real.
The other key piece I'll add too is that LLMs are not a security thing, right? So the other things you mentioned, like UEBA or machine learning for security, they took a small group of people focused on a singular problem. We're leveraging really where the world is evolving to. I mean, LLMs are billions of investments are going into, whether it's, you just mentioned Amazon or Google, whomever, to build these models, and we kind of reap the benefits of that. So it's this global trend, because we can ride on that and actually use that investment for security versus trying to take a much smaller subset and innovate that way. I think we're seeing some phenomenal kind of serendipitous discoveries, right? I mean, even simple things, James didn't get to it, but simple things were maybe simple for us to think about but not do. If you have a person on your team who doesn't have English as a native language, this can translate it to any language that it knows, probably Klingon too if you try. Like, it can translate it for you automatically. It can make you diagrams. Like, whenever someone asks us, can I do this? We're like, I don't know, let's try it. Ask the assistant and see what happens, because the power of these models is kind of unbelievable. So when we take those and can harness them in a security mindset, we can really come up with some pretty interesting technology.
Okay. Yeah. I'm going to hog the microphone if nobody else. Oh, you're standing up. Okay. You have a question? No.
Go for it. Let's go. Let's get it. I'm ready.
A couple of questions. So you're only using RAG. You didn't feel you need to do fine-tuning to get the LLM to understand security terminology better? Because I worry about that. If I understand what a bot is, what a DNS is, what an IP address is. Like, a lot of these are not common in the regular dictionary or how these models were trained.
Yeah. James will probably go in depth. I will say though, we use hybrid search, so we use a combination of like DiEM25 and RAG in combination to get the right information
Sorry,
out.
what do you use in addition to RAG?
Here, let James
Sure.
go in depth.
So
Yeah.
to answer your question, we supplement as much knowledge as we can, but these large language models know a lot about the cyber domain because there's so much to know about it. Like, there's so much public content. You have all the content from MITRE, all the threat reports in the world, all the detection rules that are in the open. So even without too much supplemental knowledge about the cyber domain itself,
So you didn't do fine-tuning.
there's no fine-tuned model here.
you just
retrieval
use RAG.
augmented. Yes.
Okay.
Which is the advantage and why we feel like it's important for you to bring in any model that you like. Because if you as an organization do have a fine-tuned model and you want to use it, go ahead. Like, if there's something specific that you want to combine that with RAG, sure. But it's, yeah, go ahead, sorry.
No, that's
Well,
fine.
there's another piece too that helps you, which is besides us pulling content out, there's also a capability where you as a user can add your own custom content into the knowledge base or the context window.
Yeah.
So we have customers that have, maybe your Fusion Cell produces particular information that you really need. You can add that Fusion Cell reports in as context. That couples with the context that we extract from our search, adds it to that window, adds it to the prompt that's been engineered, and goes up. So again, not tuning the model, but you can add more context-specific information that you want to tailor this even more specifically. Maybe it's a suspicious user list or whatever it might be. That gets added into that to make that model even more specific. And I know James touched on it, but just to add to the cautions you might be thinking about this, it doesn't have to be an LLM. We have many customers, especially in the US government, using it with locally hosted models. Take things like Mistral, be fully disconnected. Now you never have to worry about it going out anywhere. No one's training on your data sets. So it's just
But
about
do you know which LLM would have better performance for security? Do you have a view on
Yeah,
this?
he's done a lot.
There's a few. So we would so we do allow you to bring whatever model you want, but we've partnered specifically with certain vendors who have really good models. So like the GPT-4 family of models, very good, very cyber aware. The same with Anthropic's Claude 3 models, which are the latest and greatest. Very, very good, very fast, very performant, and very cheap. Google's Vertex AI, the Gemini 1.5 Pro model.
So you like them all then?
We've it's been a labor of
That's
love,
right.
but we've tried them all.
You haven't used Llama?
We've used Llama 3, we've used Mistral 8x 7b, 8x 22b, we've used Mistral Instruct. We've built in a whole evaluation framework to be able to test this at scale. So they're all really
Can you share
performant.
that evaluation framework?
It's public in our repos because all our code is public, and we can share like the methodology behind it. Yeah, absolutely.
Yeah, if you could, we can talk to you afterwards. We'll give you. We can connect. Yeah.
One last question. I'm just asking because I think that might be relevant for the audience. With RAG, you're ingesting documents or data. Like, how frequently do you update that ingestion?
Constantly, right? So if you put yourself in...
But you need to index and vectorize and all of that. So that's like happening all the
That happens in real time. In this platform, Elastic, we're a vector store as well. So we don't need to rely on any other third-party technology. So as the data is coming in, whatever we feel should be vectorized or whatever you want us to vectorize is going to happen automatically. So there's almost nothing for you to do other than set up an ingest pipeline, like your traditional data stream, and then we'll take care of the rest under the hood.
Thank you.
Yeah. Thank you.
Great questions, by the way. So.
Yeah.
Hey, quick question. What data is used by the AI to generate the calculations that you showed? Is it only the alerts or the raw events are also being used? And does the AI know how to query the relevant events to generate proper
Yeah. So right now, it's working on alert data. We have full intention for it to work on any data. The reason we started with alerts is they're a bit more predictable for us to manage the scale of these models. As the technology keeps evolving, we will evolve with it. So what I mean by that is these models started out with very small, what we call context windows, which means how much data I can send it for reasoning at a given time. Over the past year, that's gone 100x. So which means we can now do even more. So we started with this, with alerts, but the full intention is to go through any data that you have. That also means us being a bit clever in how we do the retrieval, how we run it under the hood. So that's the full intention there, to go over anything.
Yeah.
Which means, hopefully, we'll start to spot things quickly. Like if we don't have to wait for an alert to trigger it to then run a discovery, we can just start notifying of things in real time.
Yeah, the part that I think we touched on in a bit, but just also to help your question, so Elastic as a whole is a search AI platform, right? So we're the security team on top. We kind of get the benefit of that. So there's a huge team working on RAG and vectorized information and things to make it even more, we reduce the vectorized content. There's a bunch of work happening behind the scenes at that side. In fact, I think we're the largest vector database deployed in the world with Elasticsearch. So there's a lot happening there that we sort of get to ride on top of and get the benefit of as a security solution. And so all that work they're doing, it just benefits us every time they make an update or and we just put something else out recently about something we did with Lucene to optimize them to be like many X times faster, and we're really trying to contribute back to the community in general for how vector databases work. Yeah.
Okay, and maybe one last question also related to that. So you actually build your own model for that calculations, or you're just constructing a prompt with all the alerts data and
Correct.
then uses the...
Correct.
Yeah,
Elastic is in the business of building large language models. We're in the business of supplementing the knowledge to the model to make it better.
Yeah.
So this was using the publicly available, the demo we saw was using both Claude 3 Opus, which was the discovery, and then Azure's GPT-4 Turbo for the chat. Everything you'd find immediately available. Nothing's fine-tuned, nothing's different. What's different is obviously the content that we have that we've supplied. Right?
And that really matters because everyone has different cost-benefit analysis, right?
Yeah.
And some models are better at other things. In fact, you mentioned, Google's, Vertex side. They have the Mandiant data they're training in, which they haven't released yet, but they will. That's really good at things like attribution. So if you want to pay for that model to get attribution, you can, right? If we provided you a model out of the box and it didn't meet your needs, you're kind of out of luck,
So
right?
how do you overcome the size limitation of the prompt? This is why it is limited to 100
So right
alerts.
now it's, remember, this features are going to be available in technical preview to start. So we want to just have some safeguards to make sure it's going to be performant and working for users. The models that are available today are already at an adequate size to do this. So to give you an example, 100 alerts, when we do our work and our magic on them under the hood, those end up into like 70,000 tokens. Today, all the major models have over 100K token limit. So we're not too worried about anymore from the input side. There's a bit of a limitation on the output side that we're working towards. But that's why we limit it right now. Let's get the feedback. Let's make sure it's working well. Let's make sure there's no edge case we haven't thought of. And then we'll bump up that number really, really fast. That's
Yeah.
the
we
intent.
fully expect that window. I mean, Google's new model, like,
Has 1 million tokens. right now.
we think the very quickly over the past year, the models have exploded in what they've allowed, and the cost has gone way down, as we mentioned. So you'll see this technology, hopefully from everybody, but definitely from us, quickly adopt to be, like you said, even raw data. Like we want to start using this for threat hunting and other things, but first we need the models to get to the point where they can accept that massive amount of information. So,
Thank you.
thank you. Yeah, good question.
Good questions.
We have a few minutes left, so feel free to keep asking.
Okay, hi. First of all, I'm not skeptic, but cautious.
That's good.
Okay,
That's good.
about this.
We're all a little bit risk averse here in
Okay.
security.
We know that you know that LLM models has a lot of problems. Hallucination is one of them. You told that the way to get rid of this is with the data you
Yep.
train the model. But in a scale problem, how do you deal with the context length? This is the other problem of LLMs. If you have to feed with tons of data, your model, how do you produce accurate results with your context length limit?
Yeah. So I'll answer that. So thankfully, the context windows are growing. So in a few months, we're probably not going to be worrying about that. But secondly, when you apply retrieval augmented generation with vectors, because of the really in-depth similarity search that can be run with that, you can reduce the size of the content to a very, very small number.
Okay.
What I mean by that is, so if we just went, for example, and said, let's chuck everything in there,
Yeah.
that's going to be a big number. Instead, let's look for some certain pattern similarity, create vectors of them, and then send them. That number is going to reduce dramatically. We've also done improvements like, because even if you vectorize content, it can be pretty big. So even things like we've done what we call token pruning, which basically means we'll only send the tokens which count for the query that you're running. So technology is improving fast, where context window sizes, I don't think they're going to be an issue for us very, very soon, actually. Like we said, Google have already a model that has 1 million tokens, which is, this time last year, we were dealing with models with 4,000. So in a year, we went from 4,000 to 1 million, which is significant, right? So thankfully, this is all because of the competition that there is in the large language model market. And this is another reason why we didn't want to lock you into one provider. Because the second some other, whoever comes up with this model which has 50 million content, we wanted to be able to use it. So that's why we made the decision we made to allow you to use any model.
Okay. Thank you very much.
Thank you, sir.
I would like to walk you through a painful process and point out some painful points. And I would like you to tell me how you're going to help me make this less painful for my poor analysts. Somebody out there on our network has an application, a credential expires. And so one part of the application can no longer talk to the other part, like maybe a web server to a database, whatever. And so it can't connect. What's it going to do? Oh, I'm going to try again. I'm going to try again. Nope, didn't work. I'm going to try again. And the SIM says, oh my God, brute force attack. We got an alert. So the analyst gets this and strongly suspects that's what's going on, but can't prove it. And so they do look up the IP address, and wouldn't you know, that's source network address translation, everything coming in from a bunch of different applications through this load balancer,
it's the proxy
or,
loader, yeah,
or
the load
reverse
balancer.
proxy,
Yep.
whatever, is got the same source IP
You're not
address.
doing HTTP forwarding? No.
So they've got to log on to wherever we keep those logs for that SNAT, and figure out where it's actually coming from, which takes a long time.
Yep.
And then once they have that IP address, they get into our asset management database, which in our case, somehow it's in pretty good condition right now, but you can't guarantee that. But they figure out what asset, what application this belongs to, and they can't tell what this particular device does, but they know it's part of that application. And then they get on, they find out who owns it, and they get on the phone with whoever it is and say, what is that thing, and is it supposed to be doing that? And usually the person says, you're gonna have to talk to my engineer, okay, or my architect, or that guy who we brought on as a contractor and who left last year. But then they eventually figure it out and finally get somebody to issue a new credential. Oh, no, they have not issued that new credential, it turns out. So then we have to talk to the SIM engineers and say, you know what, those application owners are not taking care of it. We're still getting these alerts in, make it stop. Oh my God, make it stop. And so the engineers have to go through a whole process to do risk acceptance, because this is turning off visibility.
You just ignore them after a while. Yeah.
And so they get it accepted after going through approval from management, which takes a week while the analysts are all saying, oh my God, make it stop. And then they finally do, and they set it to this exception to expire in 6 months. That ought to be enough time for them to put in new credentials, right? No, in 6 months, oh my God, make it stop.
Yep.
Just hypothetically, of course. Not.
I can tell it's not personal
asking for
experience.
a friend.
Yeah. Well, I'll tell you what. In the interest of time, I'll give you a quick thing, and then we can always talk offline because I know we're wrapping up to the end of the minutes here. I mean, what you explained, a lot of it is that's an observability or visibility problem, right? Having the right access to the right data in the right system. What we typically find is that most people have made concessions into their SIM of what data they store, because many SIMs have been predatory in how they price things, or maybe technically limiting in how they can search things. So the first step is, I think, Log4j is a great example. Similar problem, needing to know what that application is doing. They needed application level information, not really the purview of security, although we think it is. So how do I get that data that's not in my world, it's in the IT operations world, over to my team that's in the security world? I'll just say in general, our belief is that data should be shared across everyone. There needs to be a standardized convention. We actually donated our schema to OTel recently. So the OTel has a semantic convention for both logging and security data as a standardized model where all application, logging, whatever you call it, is all in the same spot. And the goal there is you produce that central center of excellence of information, so your analyst doesn't have to go and say, I can't get past that IP address. They can go look at the application itself and see what it's trying to accomplish. Now that's the perfect world where it gets there, right? But I think visibility is the first step of security. Before we even get to cool stuff like AI, you have to have the right data in the hands of the analyst. And if they're fighting that battle, which I fought it in many places, of getting information, you're kind of unfortunately at a crossroads. Where AI does help is that feedback loop I mentioned, that automatic knowledge, that would be there when the next alert comes up to tell you, hey, you saw this before. You saw this actually 6 months ago, and here's what James did. James made an exception, blah, blah. That's part of what we've had since last July, sort of that automated feedback loop and mechanism to tell you that. Now, is it going to solve your problem? No, but at least there's a little bit there.
Oh, it would save time.
Yeah, it'll save time. So
There's
I think
also something else to add to that. So in the situation you described, there was a lot of steps someone had to follow, like, I have to find out what's happening on my NAT side. That's if they know even if it's a NAT device or whatever. So when you add custom knowledge and you do retrieval augmented generation, and someone asks the assistant, what can you tell me about this alert? If you gave it the right knowledge to say, this is a NAT device, and you're going to want to check this and this and that, then there's no more guessing work, because it's telling you exactly what procedure to follow for you to get to the bottom of something. To the point where we can actually take a step further, because we've architected the assistant, for example, to start being able to work with other solutions. So if you want to say in the future, this is future state, but in the future we'll be able to say, the assistant would like to say, it's going to allow you to do something like, would you like me to check what the IP address is on this third-party system? So taking it a step further, like the concept of agents within the AI landscape. But the whole loop with the custom knowledge, if the assistant is able to answer and tell you where to get the answer to your question, that's already a really, really big help. If it knows your network topology and it can say this connects to this and typically is behind this, that's the value here. If we can give you all of that vectorized content just by you doing like a drag and drop of your knowledge base, that's where the power is. Like that's the real power of large language models.
Happy to talk more about offline with you. If anybody else has questions, we're here. We're also at that booth up there, on the other side, other hall where you are today. But we want to say thank you, appreciate your time, and have a great rest of your day and a half of show.
Thank you, James. Thank you, Mike. Thank you to the audience for participation.